So we are going to be looking at 2f today. So 2f is looking at simultaneous equations, but it's when we've got more than two variables. So we're going to start looking at a 3D coordinate system. So that's where we're going to have x, y, and z. So when we've got a 3D coordinate system, it will give us three variables. We need to always think about it as when we're trying to locate a point, we're always going to go x first, then we're going y next, and then finally we are going to go z. So be mindful of that. Now, there's a few different ways we can look at a 3D system. So the first thing I want you to think about is what a unique solution looks. And that means we've got three planes that are intersecting at a point. We could have three planes intersecting along this line, and that means there will be infinite many solutions. We can have no normal parallel. So that just means we've got three planes form a prism. We've got two that are parallel, and we've got three that are parallel. So these are just giving inconsistent systems, which we can see that will give no solutions, because we're looking at when are all three going to be at one point, which is what we had here. All three are crossing over, and all three are meeting at this point right here. So we are going to look at solving. Now, with solving, we can do this on a CAS calculator, but we are going to focus on doing it manually today. It's the same method that we've used with solving other simultaneous equations with two. The first thing we're going to do is just look at the two equations, and we are just going to eliminate one variable. So to make it easier, I'm just going to label. So I've labeled each equation as 1, 2, and 3. We're going to pick two equations that will do equation 1 and equation 2. We're going to then eliminate one variable. So if straight away, if I write 1 and 2, they've got f that is by itself. So how do I get rid of negative f? Well, I'm going to need to take it away. So negative f, take away negative f, cancels f out. So now we've only got d and e. I can then go 2d, take away 3d is negative d, and e, take away 2e. Sorry, negative e, take away 2e is negative 3e, and negative 2, take away 5 is negative 7. So we're also going to label this as our fourth equation. So when you're doing working out, even in your SACs, if you make it clear, it makes it a lot easier for anyone to follow and mark you appropriately. The next part is I'm going to look at equation 2 and equation 3. And again, we're going to eliminate a variable. So here we've got 3d plus 2e minus f is equal to 5. And we've got d plus 3e plus 2f is equal to 11. I'm going to eliminate the same variables. I'm going to eliminate f. So before I can eliminate f and use elimination, the f's are not the same. So I'm going to double my first equation. So times every term by 2. If I do that, I can then cancel because they're the same. And to cancel, I have to plus. So the f's are cancelled, and then I've got 6d plus d equals 7d, 4e plus 3e equals 7e, and 10 plus 11 is 21. I can simplify this by factoring out the 7 and then I can divide both sides by the 7, and that gives me d plus e is equal to 3. So I will label this as 5. Now we've got only 2 equations, so I can use them again and apply elimination or substitution. So in this case, I'm just going to use elimination method because straight away I can see I can cancel out the d's here by plus e. So negative d plus d is 0, negative 3e plus e is negative 2e, and negative 7 plus 3 is negative 4. I can get e by itself now because here I've got negative 2e equals negative 4, which means e must be 2. This is where I'm going to use that e equals 2 and substitute it into an equation. The easiest one would be going back to equation 5, where it says d plus e is equal to 3. If I put that 2 in, I've got d plus 2 is equal to 3, so I take away 2 and I get d equals 1. The next step is I am just then substituting these two values into any one of these equations, and it will give me the same value of f. So I'm just going to pick the first equation because it looks a bit simpler. I will substitute d equals 1 and e equals 2, and I will solve it. So straight away I've got 2 times 1 is 2, take away 2. That just gives me negative f equals negative 2. I divide both sides by negative 1 and I get f equals 2. Let's look at the next question. Again, I've got 3 equations and we're going to solve the following system of simultaneous equations. So again, I've labelled them as 1, 2 and 3. I'm going to start off with first looking at 1 and 2, and then I will also look at the next few. So let's have a look. So with 1 and 2, I'm straight away going to write them down with elimination, and I can see z can be cancelled out straight away if I add all the terms. So z's been cancelled out, and I've got 2x plus negative x, which is x, y plus negative 3y is negative 2y, and 12 plus negative 13 is negative 1. I will then do the exact same, but with 2 and 3. So again, I'm going to write them down, and we got rid of our z, so I'll get rid of our z's again. Remember, it must be the same variable. So z plus negative z cancels out. Negative 3y plus 3y, well, that cancels the y's out, and negative x plus negative 4x is negative 5x. So we're really just left with negative 5x equals negative 15. That gives me x equals 3. So this one is a bit easier because we already have our x value right here. So I'm just going to then substitute this in to my equation of x minus 2y is equal to negative 1. So this time I'm just going to grab it and plug it in. So now I'm just going to solve for y, which means I'm going to take away 3 on both sides, and that gives me negative 2y is equal to negative 4, and then I divide both sides by negative 2 to get me y equals 2. I then grab an equation, so I'm grabbing 1 and I'm substituting my values that I know in, and I'm simplifying. 2 times 3 is 6, plus 2 is 8. I then get rid of the 8, and it becomes negative z equals negative 4, and I divide both sides by negative 1. And I get z is equal to 4.
Attention students, Trinity Jones.
So let's look at this next question. We've got the simultaneous equations shown have infinitely many solutions. X plus 2y plus 2z is equal to 1. and 2x plus 2y plus z is equal to 2. So the first thing we're going to do is we are going to eliminate y by adding the second equation to the first equation. So the first, with this, the first thing we're just going to do is write it out as we are plussing them both together, and we're just going x plus 2x, 2y plus negative 2y will cancel the y out, and 2z plus z equals 3z, and 1 plus 2 equals 3. So for B, we're looking at using a parameter symbol. So just be mindful of that. So we're going to let z be lambda and solve the equation in terms of this parameter. Okay, so the first thing that we are going to do is change z to this parameter. So that means all I'm going to do is make 3x plus 3z equals 3, and I'm just changing the z value. So we're wanting now to then solve. So the first, solve for x. So the first thing we're going to do is we're going to factor out 3. So that means we're going to have 3 in brackets, and then we're going to divide, and that will, I've just done it a different way on here, so I'll just quickly show you what I've done. Apologies, there's multiple ways of solving this. So straight away I just took the 3 and the parameter onto the other side, and then finally all I did was divided everything by 3, which is what I was going to do before, and that would get x by itself. So the algebra there's multiple ways of getting there. So now we know what x is, we are going to want to know what our y is going to be. So because we know what z is, we know what x is, so we're just going to grab these and substitute them into our equation. So that means we're going to pick the first equation, or I could do the second, and I'm going to just put in 1 minus the parameter plus 2y plus 2, and then the parameter is equal to 1. So that's where I've got this. We know what z is and we know what x is. Then I'm just going to simplify this as much as possible. So then I've got negative the parameter plus 2 of the parameter equals 1 of the parameter, and that gives me 1 plus 2y plus that parameter there. Next part is I would like to get y by itself. So if I take 1, the 1 is cancelled out, so I take away the parameter, and that gives me this, and then finally I divide everything by 2. So that's all we are doing. Now, always explaining, we're using the parameter because we know that there is going to be infinitely many solutions for this. So that's why we've got this here. And again, all we're going to do explain what this solution represents. The solution represents infinite many solutions on where the planes intersect. So I'm just going to quickly go back to show what we talked about before about infinite solutions, which is right here. So we can see that with infinite solutions, it means that the 3 planes are intersecting along a line, so it could be any one of these points that will continue to go to positive affinity and negative affinity. Okay, let's have a look. So we're going to do the same. So this time we're going to solve the following pair of simultaneous equations through the use of a parameter. So first thing we're going to do, we're just going to make that z, that parameter. And we're going to solve the equation using that value. So let's look at the second equation. X minus 3z is equal to 0. I'm making z that parameter, and then I'm going to get x by itself. So I'm just going to look at this and says I'm taking away this term, so I'm just going to add it. that tells me what my x is. We already know what z is. The final step is we are just going to substitute both of these into that first equation. Once I've substituted, I'm just going to simplify and I'm going to get y by itself. So that all that means is I'm just going to go -2 times 3, the parameter, is -6, the parameter. I'm just going to put them together and that will give me -5 parameter plus y is equal to -2, and then I'm going to add to both sides to get y by itself.